our next conic section right here we're going to be talking about is the ellipse. And this conic section, when you take a cross section of a cone and it comes down and it slices it at an angle, you'll notice that that becomes an oval-looking shape we call an ellipse. And an ellipse has different properties. We're going to be talking about those properties right now. So you should have this picture drawn in your journal, all right? So we have what's called the major axis. The major axis is the longest of the two axes, okay? So right here, this is the major axis from here going all the way across. That's the major axis. The minor axis is the smaller of the two. All right, major is the longest one, minor is the shortest. Now, the major and the minor axis will always bisect each other perfectly at the center. Now, the center of the ellipse is the H and the K values. So wherever the HK is, that's the center of your ellipse right here. Now we have some vertices. The vertices just go all the way around it. So we have 1, 2, 3, 4 vertices. Now 2 of the vertices go with the minor axis and 2 of the vertices go with the major axis. Now something you need to be aware of, I'm just going to put a couple of tick marks in blue and a couple of tick marks in blue, and 1 tick mark for red and 1 tick mark for red. So I want you to understand that from B to C is the same distance as from C to E, and from D to C is the same distance as from C to A. So those distances are always going to be equal. Now there's a couple of new vocabulary words, all right? So right here, these are called foci. Foci. So it's pronounced fo and then si. That's the plural of focus. So in ellipse, you have 2 foci. There's a focus, we'll call it focus 1 and focus 2. All right? Now, there's something, here's the definition of an ellipse. All right? An ellipse is a conic section where, kind of cool. If I go from one focus and go to any point right there, and I go from this point right down there, whatever the distance is between the focus to this point right here, I'm just going to call it an X and a Y coordinate. So I want you to think about this distance right here to here, and right here to here. That distance right there will be the exact same distance as any other point. So if I just choose a random point, let's say right about here, that will be the exact same distance from this focus to this focus. So red plus red will equal green plus green. Can you guys see how this distance does not match this distance, okay? But the sum of the 2 distances in green will equal the sum of those 2 distances in red. And that's what's special about an ellipse, no matter where you go. So if I went over here and put another random point, let's say right here, where do I have to connect this point to? I got to connect this point to the what? To the foci. Foci. Got to connect them to the foci. So if I connect this one to this focus and connect this one to this focus, now, what else do I have? I have this blue distance and these blue distances are the same as the red, which is the same as the green. Okay? So I'm just going to backtrack so we can. But that's the definition of an ellipse, where the sum of the distances are always equal from one focus to a point and the other focus to that same point. Okay? So make sure you have that. The next thing we need to talk about is all of this right here. So notice which is longer. The major axis going this way is longer, and this direction is with the x's. So we lead out with the x's. when the major axis is longer going up or down, then we don't lead out with the x's. What do we lead out with? The y value. Okay? So here, we lead out with x minus h squared. Here, we lead with y minus k squared. So we're going to go ahead and take a look at our very first problem, and we're going to write an equation. It says write an equation of each ellipse in standard form. Then it says find the what? Find the coordinates of its foci. So here we go. Does this look like it's the first equation or the second equation? What do you think? Second. So put y minus k squared over a squared plus x minus h squared over b squared equals 1. So that's what you want to do first. Go ahead and write that out. All right. What's going to be our h and our k value, everybody? Our h and our k. What's the order here? A 2 and a 3. All right. Now, everybody, something you need to be aware of. Ready? The major axis versus the minor axis. Now, if you guys go back to your chart, okay? We have this chart, and we have, hold on, this chart right here. Now, that distance from here to here, I want you guys to write, the major axis is equal to 2 times your a value. The minor axis is equal to 2 times your b value. You might want to jot those down. We're going to use that concept right now. Okay? The major axis is equal to 2 times a, and the minor axis is equal to 2 times b. So right now, let's think of our major axis. Our major axis goes from here going up and going all the way down. So if our major axis is equal to 2 times a, 1, 2, 3, 4, 5. So our major axis is equal to 10 units, which means our a value is equal to the number 5. Mm-hmm. Our minor axis goes all the way across right here. That's our minor axis. And our minor axis is equal to 2 times b. And that looks like that distance from here all the way across is 6. So our b has to equal 3. So that helps you get your b value. And we have our h and our k value. So now we can pretty much take everything and plug it in. So we're going to take our hk value, right? We're going to plug it in there and there. We're going to take our a value and plug it in here. We're going to take our b value and plug it in right there. And we'll be done with the equation.
Without plugging all the original
Y minus, what's our k value? 3. So y minus 3 squared over. If our a value is 5 and it says a squared, that means a squared has to be 25. X minus, what's our h value? 2 squared over b squared. And what is our b value? 3. So 3 squared is 9. And that equals 1. So there's your equation, everybody. There's your equation. Now there's a formula that we're going to need to find to help us find c, which is it's going to help us with our foci. So I'm going to write here, I'm going to put foci. We're going to find both of the foci.
We have to find foci.
Yep, you're going to find the foci. You're going to find the coordinates of the foci. So here's how we do it. We go back to our chart. Go back to our chart right here. Does everybody see? We're using this one. And what does it say? It says c squared equals a squared minus b squared. And could you guys write this down right now? Because this is the type of an ellipse we have. Our major axis is longer this way. So write that down on your paper. Write this down on your paper. C squared equals a squared minus b squared. All right, so write those two things down. c squared equals a squared minus b squared. And the foci are at what? H, comma, k, and a plus or a minus a value of c.
Oh, I know.
So c squared equals, what's our a squared? 25. What's our b squared? 9. So c squared equals 16. So what is our c value? Simply a 4. What's our h value? 2. What's our k value? 3. So we do 3 plus or a minus a 4. So we have two foci. So we can have, we'll call it focus 1 and we'll call it focus 2. Focus 1 is going to be at 2 comma, what's 3 plus 4?
3 plus 4 is 7.
So one of our foci is going to be at 2, 7. What's 3 minus 4? Negative 1. So one's going to be at a 2 and a negative 1. So what I'd like you guys to do is I'd like you to plot those 2 points. These are the coordinates right here. These are the coordinates of the what? Of the foci. So we have one right here. There's a 2 and a negative 1. And we have one right up here. So I'm just going to call this focus 1. I'm going to call this focus 2. And now we found the equation, and we found the location of the 2 foci. Number 2, everybody. If you look at number 2, you can see the ellipse looks a little bit different. So right now, when you look at that ellipse, what was the first thing that you noticed about this ellipse?
It's a circle.
Okay, about the ellipse, like
It's ocular.
okay, so it's longer going horizontally versus vertically. So we're going to use the first formula. So the first formula that we're going to use is x minus h squared over a squared plus, gotta put this in the wrong place, y minus k squared over b squared equals 1. So what I'm going to do is I'm going to highlight the a squared in blue and the b squared in red. And I'm going to draw a major axis going all the way through the 4, 2, and the minor axis going all the way through 4, 2. Now 4, 2 is a very important point. What does the 4 and the 2 represent? That's the H and the K. There we go. That's the H and the K. That's the center of our ellipse. Now, our major axis is always equal to 2 times the value of A. And the distance of our major axis is 1, 2, come on, board, 3, 4, 5, 6. So that's a total of 12 units all the way across. So A has to equal 6. And our minor axis is 2 times B. And that looks like 1, 2, 3, 4. So that's got to be a total of 8. So what's our B value equal to? 4. So now all we have to do is plug the information in. This is how I start every single problem where I'm trying to interpret it. What do? I draw on my major axis, I draw on my minor axis, I find my center. Alright, so here we go. Here's our equation. X minus, what's our H value?
38. Well, you better get the
Alright, take our A value, and what do? We square it to get 36. Plus y minus our k value, which is 2, over our b squared. Our b value is 4, so b squared is 16, and that equals 1. Now that was the easy part. The easy part is just building the equation based off the ellipse that's drawn. The harder part is actually figuring out what the foci are. Now something you need to be aware of: in all ellipses, c squared will always equal a squared minus b squared. This is not the Pythagorean theorem, so please don't be confused. Our a squared is 36. Our b squared is 16. So c squared equals 20. So c equals plus or minus the square root of 20. But you have to be able to break down radicals.
Oh, this is orange.
So if I broke down this radical, this becomes plus or minus 2 radical 5. Now, if you look for the equation for the foci, where are the foci located? It's going to say h plus or minus c, comma, k. If you look at your chart, if you don't believe me, that's okay. I'll just show you.
I don't.
Hey, look! The foci is h plus or minus c, comma, k. Yes. So, that's why I wrote it. So, what's our h value? 4. Plus or minus 2 radical 5, comma, k. And what's our k value? 2. So we have 2 foci. I'm going to call it focus 1 and focus 2. Focus 1, I'm going to do 4 minus 2 radical 5, comma 2. Now, Josiah, you found that to be about a negative 0.5, comma 2. That's the approximate value, okay? This is the exact value. This is 4 plus 2 radical 5, comma 2. And you found that to be about 8.5, comma 2. Here's why. The square root of 20 is approximately, also known as 2 radical 5 if you're simplifying, it's approximately equal to 4.47, which is ridiculously close to a 4 and a half. So if you're at a 4 and you take away 4.5, that leaves you at a negative half. And if you take a 4 and you add 4.5, that leaves you at an 8.5. So this right here is what I want you to write on your paper for the coordinates of the foci. These are the exact coordinates right here. These are the approximate values. The decimals are the approximate. The ones with the radicals are the exact. And then we're just going to plot them. Going to go right over here. I'm going to plot them. One of them is going to be at 8.5. So 1, 2, 3, 4.5 right there. There is one of them. And then we're going to go all the way over right here. So there's focus 1. And there is
Focus 2.
focus 2.
Yes, sir.
And that's how you guys take an ellipse, and just from looking at the ellipse, you're able to create the equation, and you're able to locate both of the foci.
Pretty cool. Right?